Welcome back to Chemistry Exams Prep. This is Dr. Kulbhushan. This question is part 2 of the questions asked by Miss Lauren. I generally don't remove anything from the question. However, I sometimes take some creative liberty to add something to a question so that the lesson becomes more interesting and it's more useful for everyone. So in this question, we need to figure out the following structures. Are they aromatic or anti-aromatic or non-aromatic? So we discussed earlier that there are 4 conditions that need to be fulfilled in order to classify a compound as aromatic. So those 4 conditions are the following. So the first one is that the molecule must be planar. So we are talking in terms of organic compounds. So a compound will be planar when all atoms are sp2 hybridized. We know that the geometry of sp2 hybridized carbons or other heteroatoms like nitrogen, oxygen, sulfur, etc., they are planar geometry, and sp3 hybridization causes the geometry to be tetrahedral. So the first condition is met when all atoms in the cycle are sp2 hybridized. Now the second condition is that the compound or species should be cyclic, which means the all atoms that are taking part in the aromaticity, they must be in a closed cycle. Alright, so the third condition is that there got to be conjugation, and what it means is that all atoms that are taking part in the aromaticity must have a p orbital, because the pi electrons can move in the resonance in p orbitals. Now the last condition is that there must be 4n plus 2 pi electrons. Now what is that pi electrons? So the pi electrons are the electrons that are in p orbitals. Let's quickly now talk about n in this formula. So we have, for aromatic compounds, 4n plus 2 pi electrons, where n is 0 or an integer. It could be 0, 1, 2, 3, 4, and so on. So n is actually not the property of the aromatic molecule or anti-aromatic. In fact, this is just a number. It could be 0, 1, 2, 3, 4, etc. So if n equals 0, then we have in this, by this formula, 4 times 0 plus 2 equals 2 pi electrons. And we saw that cyclopentadienyl cation had 2 pi electrons, and it was aromatic because it fulfilled all the 4 criteria of being aromatic. If n equals 1, then there are 4 times 1 plus 2 equals 6 pi electrons. And the most common example that anybody can quickly recognize with the 6 pi electrons is benzene. So and if n equals 2, then the pi electrons becomes 10, which is an example in naphthalene, for example. So cyclopentadienyl cation, benzene and naphthalene, they are all aromatic because they have 4n plus 2 pi electrons. Now let's quickly have a look on the species themselves and see if they classify as aromatic or anti-aromatic or non-aromatic. So if we have a look on A is, we can see the benzene ring here. It also got a negative charge. So it's got 2 electrons. Now this, the name of this anion is phenylcarbanion or phenylanion. So we know that benzene is aromatic and it fulfills all of these 4 conditions. Now the question arises, is this negative charge also taking part in conjugation, or are there 6 pi electrons or are there 8 pi electrons? Now it turns out that this negative charge is actually in fact in sp2 hybridized orbital. So these electrons are not the part of conjugation because the conjugation occurs in p orbitals. So each carbon has a p orbital which takes part in the overlapping, and that is what stabilizes the molecule overall, because the negative charge of electrons gets dispersed over the entirety of the whole molecule. And we know that if the charge is dispersed, it stabilizes the charges and the species. So species A is aromatic because it is planar, it is a cyclic, there is a conjugation, and it has 4n plus 2 pi electrons, which in this case is 6 pi electrons. Now if we look at species B, so we see that there are again 6 pi electrons. Now there is a positive charge on this carbon here, which is carbocation. So there is one hydrogen here which I just drew here. So now the question is this still fulfilling all the 4 criteria here? Is the molecule planar? And the answer is yes, because the carbocation's carbon is also sp2 hybridized, and all other carbons in the molecule are also sp2 hybridized. Therefore the molecule is planar, it's cyclic, and there is a conjugation. It's got 4n plus 2 means 6 pi electrons, and therefore this species is aromatic. This is called cycloheptatrienyl cation. Now if we have a look on species C, again it's got all sp2 hybridized carbons, which makes the molecule as flat, and there is conjugation. It's got 4n plus 2 pi electrons. In this case we have 10 pi electrons. Now so that is aromatic. Now we'll quickly define the definition of anti-aromatic compounds. So the first 3 criteria remains the same for anti-aromatic compounds. They are planar, they are cyclic, there is conjugation, and the only difference is that there are 4n pi electrons, not the 4n plus 2 pi electrons that make the compound an aromatic compound, but there are 4 n pi electrons. N is still the same number. It can be 0, it can be 1 or 2 or 3. So here now, if we see the species D here, we know that alkenes are sp2 hybridized. So we got all other carbons sp2 hybridized. The only carbon which is in question is this carbon that's got the negative charge. So there is a hydrogen here which we just drew now. So now we know that the carbon ions can be sp3 hybridized. They can also be sp2 hybridized. Now the question is this carbon sp2 hybridized or sp3 hybridized? Because if this is sp3 hybridized, then the molecule will no longer be planar. If it is sp2 hybridized, then the molecule will be planar. And it turns out that this is in fact sp2 hybridized. The reason for that is that whenever a carbon is next to a double bonded carbon or sp2 hybridized carbon and carbon gets the negative charge, then the hybridization of that carbon, which means the carbon ion, is sp2 and the geometry becomes flat. Therefore, the species D is classified as antiaromatic. Now at the same time, let's have a look quickly on H, because H is also antiaromatic. So H is also planar. It's got a cycle of atoms and there are conjugated 4 n pi electrons. So therefore the species H is also antiaromatic. Now we will have a look on the species E, F and G. So the species E, F and G, as I have noted by this color code, are non-aromatic. Now once we see any species, first of all we try to look if this is aromatic. And we go through one by one this 4 checklists. So first will be look if this is planar. So to look at that, we must draw this carbon's hydrogens. Once we draw the hydrogens, we quickly notice that this is sp3 hybridized carbon. And therefore the geometry is tetrahedral. It's no more a planar geometry like it should be in sp2 hybridized carbon, and for that reason the molecule is not planar. It's a cyclic molecule, so that's cyclic, planar, no, cyclic, yes, there is no conjugation. It's got 4 n plus 2 pi electrons, correct, because it's got the 6 pi electrons. So because it is missing the 2 conditions here, it's not planar and there are no p orbitals in conjugation, therefore species E is non-aromatic. Similarly, if we look at species F, we notice that this species is just the result of the protonation of pyrrole, and pyrrole was aromatic as we saw yesterday. However, once you protonated the pyrrole's nitrogen, the geometry changed here. So this became sp3 hybridized nitrogen, and therefore the geometry became tetrahedral. And for that reason, this species is non-aromatic. Now about G is the its name is cyclooctatetraene. there are 4 double bonds here, and 4 double bonds means that it's got the 8 pi electrons. So it has 4 n pi electrons, means 8 pi electrons. So if everything else checks out, then this should be classified as antiaromatic compound. However, this is not antiaromatic. The reason for that is because the shape of this molecule is tub shaped, and the reason for that is that these carbons, they try to minimize the energy, and in order to avoid that being anti-aromatic, they change their shape, and the molecule takes the shape of a bathtub. Therefore, this species here, cyclooctatetraene, is non-aromatic. So now let's recap the main points here in this lesson. So any species, if you want to classify it to be as aromatic, must fulfill the 4 criteria. It's got to be planar, cyclic, and there must be 4n plus 2 pi electrons in conjugation. And for a species to classify it as antiaromatic, the first 3 conditions must be fulfilled, and the number of pi electrons must be 4n. And anything that does not classify as aromatic or antiaromatic will be non-aromatic or not aromatic. Alright, so thanks for watching. If you have any questions or suggestions, please write in the comments, and I'll make sure that your comments are included in my next video.